Okay, so we're going to talk about today, similarity transformations. And, you guys have talked about congruence transformations before. That's like your flip, your rotate, or your turn, and your slide, or the translation. Okay, we've not really talked about those in here yet, but we will. Okay, those are all congruence transformations. If you take a triangle and you slide it, it's still the same triangle, right? If you take a triangle and you flip it, it's still the same triangle, correct? If you take a triangle and you rotate it, it's still the same triangle, right? Those are all congruence transformations. But there's one that's called a dilation, and this is called a similarity transformation. And this is like taking a triangle, going down to the copy machine, and reducing or enlarging it, okay? It keeps the same shape, but the size of it changes, okay? And it stays proportional to each other, okay? And so this is called a similarity transformation. The center of dilation is the fixed point from which the dilation is performed. So, like, I've got an example of two dilations, one where it's a reduction, one where it's an enlargement. This point P and point C here, that's called my center of dilation, and that's the fixed point from which the dilation is performed. Not a huge deal for what we're going to do, because we're not going to actually construct these, but we will talk a little bit more about that in just a second. Now, scale factor. Okay, we talked about what scale factor was with similar triangles, right? It's a ratio of the side lengths reduced, yes? And they usually specify the order in which they want you to do it. Well, in a dilation, there's a specified order in which it needs to be done. And the order in which it needs to be done is the image over the pre-image, okay? Now, the image is the result. The pre-image is the original, okay? We use the letter K when we talk about dilations to talk about scale factor. So if we look here, this right here is an enlargement, okay? We're going from blue to green, okay? This is an enlargement. And notice how the blue has the letters A, B, C, and the green has letters A prime, B prime, C prime. When you talk about this, your primes are your image, and then the ones without the primes are your pre-image. And so when you go to set it up, you take a side, let's say side A, B, and the original goes on the bottom, and the enlargement or the reduction goes on the top, okay? So it's image over pre-image. Now, if your scale factor is greater than 1, it's going to be an enlargement. For example, if this right here was, let's say, 2, and this was 4, okay? Then if I did my scale factor, this is my image, this is my pre-image, I would do 4 over 2, which is 2. That number is greater than 1, so that tells me that it's an enlargement, okay? This one is a reduction. And so let's look at the sides PS and P prime S prime. Let's say that this is a 6 and this is a 3. Well, this is my primes, and this is my image, this is my pre-image. So it's image over pre-image, so it would be 3 over 6, which is 1/2. Anytime your scale factor is between 0 and 1, it's a reduction, okay? All right? So if it's greater than 1, it's an enlargement. If it's between 0 and 1, it's a reduction. And your scale factor is always image over pre-image. And your image is your result over your original, okay? Result over your original, all right? Okay. So if I look at these here, I want to determine whether each dilation is a reduction or an enlargement, and we want to find the scale factor. Now you can kind of just look at it to determine if it's a reduction or an enlargement, but notice that the blue is my just my A and my B, and the green is my A prime B prime. So in this case, the blue is my pre-image, and the green is my image, okay? And remember, your scale factor is image over pre-image. So what I need to do is I need to take a pair of corresponding sides. So we're going to look at AB and A prime B prime. And AB has a length of 1, 2, 3, 4, 5, 6, 7, 8. A prime B prime, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? So I want to compare these, and remember, it's image over pre-image, so So what should I do? How should I set it up? 16 over A, which is 2. And that tells me that it's an enlargement. Okay, so then we come over here to this one. And again, the blue is my pre-image and the green is my image. If I look at the length of AB, that's 1, 2, 3, 4, 5, 6, 7. And then my green is 1, 2, 3, 4. So to get my scale factor, how do I set it up? Remember, it's image over pre-image, so that would be, what'd you say? 4 to 7, so 4 over 7, which means this is a reduction. All right. So now this one's a little different because this one's taking the center of dilation into effect. If you don't actually use the side length, you can use a point's distance from the center of dilation. Okay. And so, like, Q is my pre-image and Q prime is my image. So you can look at this point's distance from the center of dilation. And what is this distance going to be from Q to C? It's going to be 10, right? And then the distance from Q prime to C is 15. Okay? And so it says determine whether the dilation from Q to Q prime is an enlargement or reduction. Well, you can tell by looking at it that it's what? From Q to Q prime is going to be an enlargement, right? So my scale factor needs to be greater than 1. Yes? Okay? And so we look at the distance it is from the center of dilation. And so what goes on top? Your image, right? Which is, what's this image distance from the center of dilation? 15. And this Q's distance to the center of dilation is 10, right? And so then this reduces to be what? 3 over 2. Okay? So that's the scale factor, 3 over 2, which is 1.5, right? That's greater than 1. It is an enlargement, so we're good, right? Okay. Okay. A photocopy of a receipt is 1.5 inches wide and 4 inches long. So we have a receipt here. It's 1.5 inches wide and 4 inches long. By what percent should the receipt be enlarged so that its image is 2 times the original? What will be the dimension of the enlarged image? If you're gonna increase something 2 times, by what percentage is that? 200%, right? So that answer would be 200%. And so then to figure out what the new dimensions would be, I would take each dimension and I would multiply it by 2. So I say 1.5 times 2, which is 3, and 4 times 2, which is 8. So my new figure, or picture, would be 3 by 8, right? If you go down to the copy machine, if you want to copy something exactly the way it is, you choose the 100%. It kind of defaults to that. If you want to make it bigger, then you go up, upwards in the percentages. And if you want to make it smaller, you go downward in the percentages. All right, last one. Christine created a decal from the Owasso Rams logo. Is the decal a dilation of the original logo? If so, what is the scale factor? Okay, so what do we have to look at to determine if it truly is a dilation? What has to be true about these dimensions? They have to have the same scale factor, right? They have to be proportional, right? Just like if you look to see if something is proportional. So how would I test that? What would I compare? Side to side, width to width, or height to height, width to width, okay? So if I did 15.6 is to 5.4, and 15.6 is to 7.8. 15.6 is to 7.8, and 5.4 is to 2.7. And so what am I going to do to test that? Cross multiply, okay? Could I just reduce those fractions? I could, yeah, because if I reduce both of those, they're both going to be 2, right? If I cross multiply, I'm going to get 4212 equals 4212. So either way it works there. okay, to determine that. So, yes, this is a dilation. Now, I need a scale factor. And remember, your scale factor is image over pre-image, okay? So I've got to take a dimension from the image and then set it over a dimension from the pre-image. So what would that look like? 2.7 over 5.4. 2.7 over 5.4, okay? And I can move both of those decimals over and have 27 over 54, which reduces to be 1/2, right? Some of us can just recognize that 27 is half of 54. Okay, so what does it mean to be a dilation? Okay, you reduce or enlarge proportionally, right? So they have to, the dimensions have to be proportional. And what, how do you find the scale factor? Image over pre-image. And what's the image in real words? The result, right? And the pre-image is the original. Okay, good. All right, in order to be a enlargement, the scale factor has to be greater than 1, and to be a reduction, it has to be between 0 and 1, like fractional percentage. Okay. All right, any questions? Okay, I know it looks like a lot of work, but you'll have the entire day tomorrow to work on both of these. Okay, so don't take it home tonight and do it all and then have nothing to do. Okay, kind of. But, you know, pace yourself. You can get one done and maybe work on the other one in class tomorrow. I do have a couple of things that you need to look at here in the first lesson. Number 2, the way they have the numbers is kind of backwards. If you set it up, you get the right answer, but they have this is 9 and this is 6, and your height cannot be greater than this, okay? So I switched both of them there. In lesson 7-6, the blue, it doesn't have primes, and so the blue is your pre-image and the green is your image, okay? Okay? Stop.